In this learning activity, we're going to look at the concept of a ball and socket joint. Our learning intentions are to apply design thinking, creativity, innovation, and enterprise skills to develop, modify, and communicate design ideas of increasing sophistication. In able to demonstrate that we've done this, we're going to manage components in Fusion 360. We're going to create a rotating ball and socket joint. We're going to experiment with setting variations to understand the effects within the ball and socket joint. And we're going to create a model with multiple moving parts. The concept of a ball and socket joint involves basically creating a ball that connects to a body of some sort and a corresponding socket which fits the ball inside and allows a fair amount of rotation and angular variation. The parts that we're going to be quite concerned about in drawing are the ball stalk, the socket, and the socket slot. Our first step will be to draw the sketch for the ball, and we'll do this by drawing a half cross section of the ball, and then we'll use the revolve tool to create the solid. So here we are in Fusion 360, and we're going to start off by creating the ball section of our ball and socket joint. So basically I'm going to start by hitting create, and I'm going to create a new component. And components are probably something you haven't seen me work with yet, but it's a good idea when you're making things with multiple parts to use components. So this is going to be the ball section. So let's actually put the ball in there, and it's going to be an empty component, and I'm going to click on OK. You'll now see that this component is the active component, so everything I draw will be managed in this little folder here, as opposed to being just part of the main folder, which will get confusing if we don't separate these things out. So I've got this ball here. I'm now going to create a new sketch, and I'm going to start by creating a circle sketch. I could use the arc tool at this point, but I'm going to start by using the circle tool. Just going to draw the circle on this back plane here, and I'm going to start by drawing the circle, back in there, and here in the middle, and setting it out to be 20 millimeters. Press enter twice. So I've now got a 20 millimeter circle. I'm going to zoom out a bit. I'm now going to draw a line. I'm just going to draw the line anywhere from here all the way down. Make sure it's, you can see now, you can see this blue constraint appears about halfway up that line. That's to say that it's going to be vertical. So I'm going to come out here. I'm going to come out about this far. I'm going to go up about this far. Go across to about here. And then I'm going to end up, I'm going to zoom in so that I don't hit that tick. Once again with a perpendicular constraint there. And I'm going to end up there. The next thing I'm going to do is I'm going to trim these things off. I'm going to trim off this outside line here and this internal line here, and you can now see that I've got this set nicely. The next thing I'm going to do is going to line this up with this center green line here. So I'm going to use the coincident constraint to make this point here a coincidence with this line here. I'm now going to use the dimension tools now that I've set this to actually just close these last guys off. So that's going to be an 8 millimeter. I'm happy with that. This line here is going to be, let's make it 3 millimeters. This height here is also going to be 3 millimeters. And this distance from here to here, we'll leave it at 2 millimeters. Now the whole sketch is black. That means it's a fully constrained sketch. So all the dimensions and constraints are set that nothing will ever move. So I'm happy with that. I'm going to hit stop sketch. I'm now going to use the create tool, and I'm going to create a revolve. I'm going to use this as the profile. I'm going to select the axis being this line on the edge here, and you can see now I now have my body in my ball, which is good. Just going to go into where is it? Modify appearance. That's what it is. I'm going to choose one of these plastics. I'm going to make it green. So I'm going to drag that green onto there, so that my ball is going to be a different color to my socket, which I'll make in the next part of this tutorial. Step 2 involves creating a socket sketch. In this case, we sketch out the socket profile, which is actually shown in the top section here, and we'll use the revolve tool for that. You'll note that the magenta sketch in this particular sketch is a projection of the ball sketch, so that I could use it as a reference point while drawing the entire diagram. So we have our ball. We now need to activate this, our main tutorial, our main file up here, and I'm going to create a new component in the main file up here, and this new component is going to be called my socket, and it will by default come active, and the ball will go quite transparent. The one thing I'm going to do with the ball is I'm actually going to turn the bodies off, but I'm going to reactivate this sketch so that I can see it there. So if I go to the front view there, so front view there, I can see that that sketch is there. And I can now create my socket. So I'm going to create a socket sketch in here on the basis of this particular sketch here. And you can see it's the other way around to what it was before, but we can still cope with that. So I'm going to create a new sketch. Once again, I'm going to start with circles, and we're going to create the sketch on this plane here, and we're going to start once again from the center, and this time 20 won't be right. We're going to go to 20.5, which is going to be slightly larger, so the inside of the socket will be slightly larger than the ball, which makes sense. That way it will fit inside, but it won't be touching. We're now going to create the outside of our socket, so I'm going to create another circle, and this circle is going to be basically 23 millimeters, which means that this wall is going to be 2.5 millimeters thick. I wouldn't go any thinner than that for this particular type of experiment or socket. Now I'm going to start with our lines. So remember, our line last time went from this outside point up here to around about here. And we went over somewhere over here, and we did something like this, and we maybe go over here, and we can join up with that one there. So you can see that I've got the outside of my line. I now trim off the excess. So I'm going to trim off this one and this one. I also don't want this one. I don't need this one in the middle either. So you can see that I've got the outline there working for that. I now need to set the angle, what I would call my socket angle, and my socket angle is the angle between this red line here, which is one of my axes, and the edge of the end of the socket. So I'm going to create a line here, and I'm actually going to draw a line out this way, and I'm going to hit the tick box there. I'm going to press on this line to select it now, so I'm just going to use the select tool to select this line. So you can see it's blue now, and I'm going to use the construction tool to turn that into a construction line. You can see there it's a light color there. I'm now going to draw another line out this way, and once again I'm going to use the tick button to actually create that line, and I'm going to set the angle by using the D key for dimensions on this one here and this one here. You can see the angle here is the angle I'm going to use, and as I have on the presentation, I'm going to use the angle of 27 degrees. So now I'm going to start trimming stuff off. Now that I've got that 27 degrees going, I'm going to trim off this line here. Don't need that line there. Don't need that little one over there too, so that's gone. Don't need this inside line. Don't need the outside line. So you see I've got that 27 degree happening there. So I'm actually going to now put a fillet on there. So I'm going to choose fillet. I'm going to put it on that little one there, and I'm going to set it to be about 1 point, maybe 4. Actually, I'm going to go 1.2 millimeters so that it doesn't go too far beyond there, and it works quite nicely. And that should be fine. So now that I've got that, I'm going to just quickly set the rest of these. So let's look at our dimension here. For some reason, this dimensions on this is lost. So I'm going to click over here and press the D key, dimension. It's giving a radius this time, radius of 11.5. That's fine. I'm going to give this distance here. Let's just keep that back at 3 millimeters, so it's consistent with before. Let's make this one also 3 millimeters. You can see that's just gone a bit crazy now, so let's put a constraint on that to make it that way again. And you can see that that one's also needing that constraint, so some of those lines weren't constrained properly. Now I'm going to press the dimensions here and set this dimension here to be 2 millimeters. You can see now that this is not actually right. So we need to basically join it up with this line here. It could be a bit tricky to join it up with this line here. So what I can do is I can actually use the collinear line and click on this line here, which is from my previous sketch. And this line here, that's actually the line from a sketch that we actually have. If you don't have that line lit up, you can use the P key to project it. So I hit P and I'll project this one, for example. Now that's lined up. Hit P, project this one, this one, this one, and this one all around. Now that whole sketch is projected in, but I won't be using that. It's just to help me see it, really. So now that I've got that collinear, that's going to work. This only section now that I need to define is in dimensions, is the length from here to here, which I believe I was going to have at 8. So now I've got my sketch. It's all constrained in black except for this one radius here, which is a slight problem. So what I'm going to do is I'm going to delete this off here. I'm going to draw another line. This time it's going to be a construction line, so I'll click on the construction line, going from the center point again. And you can see now I've got it constrained to that point there like so. And I'm going to press tick. So that's a construction line. And what I'm going to do is I'm going to use the tangent to actually make this and this line a tangent. And what that will mean, I also need to make this point here. We've got a bit of a problem here. If we zoom up really close, we can see we've got 2 points there. So this point here and that point there need to be collinear, as do those points. So now, in theory, if I go diameter, dimension here, and the dimensions between these two, I'll get 27. Press enter. If I want to change those, the whole thing will move now because it's all black. If it's not all black, you can't do that. So you need to make sure it is. Let's just put it back to 27. And you can use that as a way of doing experimentation in order to change that setting. So now I'm going to hit stop sketch. And basically I'm going to use, once again, the create tool to create a revolve. I'm going to revolve this. I'm going to ignore that. And I'm going to select the axis to be this. And there we have it. There is my socket. Not quite complete yet, but that's the socket as it is at the moment. Step 3 is our final step, and we'll need to install a socket slot. The socket slot is simply a rectangle drawn on the center plane and extruded through all of the socket to cut the slots out. So we're looking at our socket now. I'm going to press A key and bring up and just make this blue, just so I can see the difference between it and the green. Hit close down there on that. So basically we're going to put our slot into our socket. It's important that we just completely turn the ball off. I'll just show you the ball there. You can't see it because it's faded out because we're actually still in our socket edit mode, or this is our active component. We actually make that our active component. You can see that the ball is green. If we make our ball the active component, you can see the other thing fades out. But we need our socket to be our active component, and we need to lock the ball off so that we can't see it at all. And if you don't see it, you don't edit it. That's the way it works. So we're going to basically create our slot now. And I'm going to create a slot by drawing a rectangle. And I'm going to draw a rectangle in one of these planes, these upright planes. So not the base plane, but that plane will be fine. Either one of the two that are upright will be fine. Now I can start my rectangle as far down as I want. As long as I go up above the middle point, should be fine. So there's my rectangle, and I'm going to basically do some dimensioning now on the slot. I'm going to dimension this from this point here to this point here. It's going to be 8 millimeters, and this distance here we're going to have it at 2 millimeters, and I think you'll find that's perfectly on now. But from the center point to this point here, we'll make that 1 millimeter. Let's drag that out. I like that. I like these to look like that, actually, especially the smaller ones. So basically you've got 1 millimeter there, 1 millimeter there, and that's all you really need to do. If you don't like this hanging out the end, you could also just say that that's going to be collinear. So this one here is collinear with this one here. So that's just not going to hang out at all. That makes it nice and neat. So now I'm going to stop the sketch, and I've got this sort of rectangle hanging around in the middle of this, doing not a lot. So basically, let's actually do our modify. So we're going to choose modify. We're going to select our rectangle, and we're going to choose over here 2 sides, and for each extent we're just going to go through them all. So that's going to go through all of that way, and this one's going to go through all of the other way, and it's going to be cut, and we're going to click OK, and that is done. So basically that is our joint that we've made. One of the things you might want to experiment with is actually curving this off. I think curving it off might make it just look a bit nicer, if nothing else. So we've got that made. If we actually turn our ball back on now, so there it is, ball's back on there. You can see that the ball has not been cut through. Let's just turn or activate the main component, and we can see there that we've got our ball and socket joint working quite well. Now only fact needs to be that you need to make it, so you need to press the make button, uncheck this box here, and let's click on the top one. Once we click on the top one, because I've got preview on, it's going to preview the mesh and see what it looks like, and then you should be able to press OK and save that, and do a similar thing to the ball as well. If we experiment on various attributes of our ball and socket joints, we will be able to improve them or understand the effects of those settings. The first setting we're going to look at is the ball stalk length. If you change that length down there on the ball stalk, what are the implications, especially of a really short or non-existent stalk? So if you actually put the ball and attach the ball directly to the body, what would that be if the effect be on the function of the ball and socket joint? Another question you might ask is, what would be the effect of changing the inner radius of the socket, which is the first radius of the circle that we drew? The inner radius, if we set it closer and closer to 20, which is the radius of the ball, then we should have a different effect. Another thing to experiment is to change the socket angle. The socket angle is defined in this tutorial as the angle below the midpoint of the extension of the socket. If I made that smaller or larger, what will the effect be? Another thing we can experiment with, which is not so much in the design phase, is what is the effect of printing the ball and socket in different orientations. For example, printing them sideways like I am here, unlike most of the prints I do for testing these, which is in an upright orientation. Our learning activity will be to choose one of the experimentation questions and answer it by physical experimentation. That means that you need to change the settings and print multiple copies and actually feel the difference and see the difference in the effects. You'll also be required to create and 3D print a ragdoll model of an animal. Say, for example, you might want to do an octopus and use the socket joints to create the limbs.